This is an elastic string question where we have a string which is at full value. So let's have a look. The natural length of the string is 0.4 meters. And we're not told the modulus of elasticity, but we are told that it is stretched down to a level of 0.6 meters below where it's fixed. Now there's a mass of 0.5 kilograms on the end. So it stretches, it's elastic. You can see it stretches an extra 20 centimeters. So the x value here is 0.6 minus 0.4. So it's stretching by 0.2 meters. Now, this is just hanging naturally. So this is at equilibrium now. So if it's at equilibrium, what is the modulus of elasticity? So part 1. The modulus of elasticity is the formula, the tension equals modulus divided by natural length times the stretch. Now if you've got 5 newtons acting under the weight, then you have a tension of 5 newtons. So 5 newtons equals whatever the modulus is, divided by 0.4, and our stretch of 0.2. Therefore, the modulus is 10 newtons. Now, knowing the modulus is 10 newtons, we're told that it is projected upwards and it comes to rest 30 centimeters above. So it comes to rest here, 0 meters per second, when it's 0.3 meters traveling. So let's have a look at this. It comes to rest, it's projected up, and it says, well, what is the initial velocity? So step 2, what is that initial velocity? So it comes to rest at 0.3 meters above that point. So we're going to look at the 3 energies at this point where it's projected up and at this point where it stops. Now those 3 energies are, I'll just put it in here, kinetic energy, potential energy, and elastic potential energy. So let's have a look at our kinetic energy is half m, whatever the v squared is. Elastic potential energy is our modulus of elasticity divided by 2 times our natural length times our stretch squared, so 0.2 squared. Our potential energy, we've got no height, so mass mg times 0. Okay, so that's our energy at the bottom. Now let's have a look at our energy at the top. Let's change the color. Let's have a look at the energy at this point here. So the sum of, now our kinetic energy is 0 because it's half m 0 squared. Our elastic potential energy is 0 because there's no stretch anymore. And our kinetic energy, our potential energy is mgh, which is 0.5 g, and our height. Now our height, it's moved 0.3. So that's what our sum at the top would equal, 0 plus 0 plus 5.3, 1.5. Now equating these two, the red and the blue, 1.5 will equal half mv squared plus 10 times 0.04 over 0.8. Okay, so we equate that. Therefore, when you do your formula here, when you take v squared, so 1.5 equals 0.25 v squared plus, and that's 10 divided by 20.5. So we will have 1.5 minus 0.5, which is 1, divided by 0.25, which is 4. Therefore, v squared equals 4. So v equals 2 meters per second. Okay, so that's part 2. Part 3, I'll do a follow-up. Part 3 is what happens after it starts falling again. What is the stretch factor in the subsequent motion? So until the next part, or until I help you again, stay happy.